This question is about metals and their compounds. State why the atomic radius of calcium is greater than the atomic radius of magnesium. Well, if you look at them in the periodic table, you can see that calcium is lower down the group than magnesium. So calcium has more shells than magnesium, and that's why it's got a larger atomic radius. Magnesium reacts with steam. Says given equation including state symbols, so magnesium is a solid, steam is a gas. When it reacts, we get that bright white light, we get white solid of magnesium oxide formed, and we get some hydrogen gas being formed. Similar sized pieces of barium and magnesium, so in the group 2, magnesium's near the top, barium's near the bottom, are added to separate samples of sulfuric acid. In each case, the sulfuric acid is in excess. The barium reacts quickly at first, but after a few minutes the reaction stops, even though there is still some unreacted barium in the flask. The magnesium reacts more slowly than the barium, but the reaction continues until all the magnesium has reacted. Explain why the barium initially reacts more quickly than the magnesium. So barium is more reactive as the outer electron, because there's 2 that we're going to lose, are further, because it's got more shells, further from the nucleus. So there is a weaker nuclear attraction and they are lost more easily. So then it says the barium reaction stops before all the barium has reacted. So barium reacts with H2SO4 to form barium sulfate, which is insoluble. The barium becomes coated with barium sulfate and therefore no more barium can react. The acid can't get in to the barium to react with it as it's coated in this insoluble barium sulfate coating. A metal nitrate, XNO3 twice, completely decomposes when heated. So a 0.832 gram sample decomposes on heating to produce a total of 348 centimetres cubed. So that is 300. This is obviously a PV equals nRT, so I'm going to turn it into meters cubed by dividing by 1,000,000. Temperature's already in Kelvin, so that's good. Pressure needs to be in pascals, so 100 kilopascals is 100,000 pascals. Now the number of moles is the tricky bit because we've been given the number of moles of X bracket NO3 twice, or we've been given the mass, so we can't actually work out the moles, can we? Because we don't have the MR because we don't know what X is. So that's the mass of that. Let's work out the moles. So if PV equals nRT, then N equals PV over RT. Let's put our numbers in. 100,000 pascals times 348 times 10 to the minus 6 meters cubed, divided by 8.31 times 298. So let's put that on our calculator. And that's coming out as 0.01405 moles. But that's moles of gas, because PV equals nRT is going to give us moles of gas, because it's the gas equation. So we need to go back to our chemical equation and look at how many moles of gas we've got. We've got 5 gases for every 2 nitrates. So the ratio between the gas that we've got and the thing that we want is 5 to 2. So the number of moles of X bracket NO3 twice, we want to go from the 5 to the 2. So it would be 2/5 of our number. So 5.62 times 10 to the minus 3 moles. And now we've got the mass and the moles, we can work out the MR. So it was 0.832 grams. (148.0). So that's everything. That's X brackets NO3 twice equals 148. So the X plus, we've got nitrate, so 14 for nitrogen and 3/16 is 48. Add the 14 is 62. So we've got 2 lots of 62. Okay, so we need to do 2 lots of 62 equals 148. So we're going to subtract 2 lots of 62 from our MR, and we're getting 24. And so if we look that up in the periodic table, then the closest thing that we can see is magnesium, and it makes sense to be magnesium because this is definitely the formula of something with a 2+ charge, because a nitrate ion is 1-. The next bit says sodium reacts with aluminium and hydrogen. So sodium reacts with aluminium and hydrogen to form sodium aluminium hydride. Now we just need to balance that equation. So if we have a look, we've got 4 hydrogens, so we're probably going to need 2 H2s. Suggests why it has a high melting point. So if this has got a metal in it, sodium's going to be a positive ion, which means the rest of this is the negative ion. It's like when you do sodium borohydride. So this is ionic. So we want to say there are strong forces of attraction, ionic bonding, forces of attraction between Na+ ions and AlH4- ions, oppositely charged ions. Give the reaction for the equation between an excess of NaOH and phosphoric acid. So we've got an acid here and a base, so we're going to make a salt. So we take the metal from the base, and then the anion from the acid would be a PO4 3-, so we're going to need Na3PO4, salt plus water, and then we're going to need to balance our equation. So we're going to need a 3 in front of sodium hydroxide and a 3 in front of water to balance it. Lithium is an important metal used in cells to power mobile phones. In a lithium cell, lithium cobalt oxide electrode and a lithium electrode are used. Give an equation for the reaction that occurs at the positive electrode. You have to just remember this. So this is the lithium ion and the cobalt oxide react, and at the positive electrode reduction happens to make the lithium, and then we have the cobalt oxide negative ion. Commercial electrochemical cells can be rechargeable or non-rechargeable. State why lithium cells can be recharged, and that's because the electrode reactions, so the one at the positive electrode and the negative electrode, can be reversed.